Hello and welcome. Today we're going to talk about measures of variation. Now, in the last section, we did briefly talk about variation as to whether a data set may have small, medium, or large variation, but we didn't really calculate the actual values for the amount of variation a data set has. So the first thing we want to look at is calculating the range. The range is simply just the max minus the min. It's the furthest distance between any 2 points in your data set. The following numbers are exam scores from a sample of 9 students, and we're going to find the range of the exam scores. So in this case, we have the max, which is 100, and the smallest number is 25. So 100 minus 25 is 75. So this is the range. The next way we can look at variation is by looking at quartiles. And quartiles basically split our data set into 4 parts, where we have the lowest fourth of our data set. All those numbers will be less than the lower quartile. Then we have the middle quartile, which separates the lowest one half of the data set from the upper one half. Notice that this is the exact same thing as the median. Then we have the upper quartile, which separates the bottom 3/4 or 75% of the data set from the upper 1/4 or 25% of the data set. Let's find the 5-number summary for the following exam scores. To do this, I'm going to go ahead and rearrange this again from smallest to largest. So last time we did already look at the median, and we ended up finding that 84 was the middlemost number. Notice that it has 4 numbers on the left and 4 numbers on the right. To find the first and third quartiles, we basically would ignore the median, and what we basically would do in that case is we would look at the median of the bottom half and the median of the top half. So the median of the bottom half, we would need to average 62 and 76 together. So we get 138 divided by 2 is 69. Averaging 88 and 92 together, and we end up with 90. These averages are Q1 and Q3. 5-number summary, we have 25, 69, 84, 90, and 100. So what can we do with these 5 numbers? Well, with these 5 numbers, we can go ahead and make box plots. So with the 5 numbers, we can go ahead and make a box plot. And the box plot would allow us to create a way of figuring out what our spread is. So what I'm going to do now is I'm going to go ahead and draw the box plot for this data set. Basically, I'm going to just look and see where 25 is. That would be about right here. We have 69, which is almost 70, 84, 90, and 100. Now the middle 3 lines are going to be part of the box, and then the outside lines are going to be where the whiskers are. And we can definitely see that there's a lot more variation in this left tail than there is anywhere else. So this is actually going to be a left skewed distribution. The last way we're going to look at our spread is by looking at the standard deviation. Standard deviation is a measure of how far data values are spread around the mean of the data set. And we do this by using this formula. Now, this formula is a little bit hard to understand without looking at an example. The mean is 39.2. And the best way I can suggest trying to find the sample standard deviation is to basically make a table. So I'm going to list out the x values, x minus the mean, and then it'd be x minus the mean squared. So our x values are 32, 38, 39, 42, and 45. So for the first example, x minus the mean would be 32 minus 39.2, and we end up with negative 7.2. Following this pattern, we end up with negative 1.2, negative 0.2, 2.8, and 5.8. to find x minus the mean squared, we're going to take each of those numbers, so negative 7.2 for example, and we're going to square that. Now notice that I have to put the negative inside the parentheses, especially if I'm doing this on the calculator. So when I do this, the negatives should always go away, and in this case I have 51.84. And I continue on, so negative 1.2 squared will be a positive 1.44. So what's the next step? Well, let's just look at what we have here. What we have is we basically did this part, where we took each data value minus the mean and then squared it. So what's the next part? Well, the next part says to sum. So we need to add all of those together. The sum in this case ends up being 94.8. So now we have 94.8. We can go ahead and divide this by the total number of data values. So we have 5 data values minus 1 is 4. So we need to divide this by 4. And we get 23.7. 23.7 actually gives us the variance, which is just simply the standard deviation but squared. So if we take the square root of 23.7, which will give us a not very fun number, we get 4.868, and this is our sample standard deviation. Now I know that was probably a lot of fun, but there is a way to estimate the standard deviation, and it's simply just to take the range and divide it by 4. And I'll admit that this formula does not always work very well, especially if there's outliers. We can also estimate the max and min values with the following formulas, where we take the mean plus or minus 2 times the standard deviation. Now for this, we're just going to use the range rule of thumb to approximate the standard deviation for that last data set that we looked at. So we need to first find the range. So the range was 45 minus 32. So this ends up being 13. And if we take and now the range rule of thumb, our standard deviation is approximately equal to 13 over 4, which is 3.25. Now compare that with 4.868, it probably isn't that great of an approximation for that example. The point of the range rule of thumb is to kind of give you a rough idea without having to do any serious calculations on what the actual standard deviation should be. This is all I have for this section, so thank you for watching.